Starting from kinematics, we have two quantities. The first one is distance and displacement. Displacement versus distance. Okay, so displacement is going to be a vector quantity and distance is a scalar quantity. Now, the difference between these two are explained in another video. You can go check that out. So, vector, in terms of vector, displacement will be considered as the shortest distance between 2 points, right? So, or you can say between your starting point and ending point, wherever that starting or ending point may be in terms of the journey. And distance is the total length of path between 2 points, irrespective of their direction. It does not matter what direction they are in. What matters is what is the total length between the 2 points. So, for example, if this is point A, this could be your home, and this is point B, this could be your school where you want to go. It does not matter what path you take. It could be a series of straight lines. It could be a curved path following the roads till you get to B. So whatever the length of this path is will be the total distance. It does not matter what the direction was while you were covering this distance from A to B. And similar case is when you go back from B to A. For example, if you go from B, do some grocery shopping, let's say, and you take a different route back home, it does not matter what distance or what method you take. What matters is the distance or the length that has been covered between the 2 points. So there is no specific direction of this journey. Similarly, if you talk about displacement, for example, you start from point A, you finish at point B, it will matter what is the eventual direction that you have actually moved towards. Now, it's possible that you move downwards, let's say towards this side, then you go to this side, then towards this side, consequently covering such a path and eventually making your journey to point B. Now, if you want to figure out the actual displacement between these 2 points, what you need to figure out is the shortest distance. So if you were to travel in a straight line from point A to point B, what would you have done? Now, a common example that I generally give my students is that if you had a helicopter, what would you have done to move from A to B? Would you have followed the roads? No. You would have traveled straight to point B from air in this way, right? So this green line represents your displacement in these circumstances. In these circumstances, the red one represents your distance traveled. And notice that displacement has a specific direction. Now, for example, let's recreate this in a new diagram, right? So by this time, I hope that we understand what is distance and displacement. Now, let's create this example again. Let's say this is point A and this is point B. The shortest distance between these 2 points will always be a straight line like this one, right? And on this diagram, we are not drawing the previous distance that we have done, the path that is shown in red color. We're just going to discuss displacement. So now displacement is a vector quantity, and for any quantity to be a vector, there needs to be 2 things associated with it. The first one is supposed to be the magnitude. Now the magnitude defines what is the value. For example, is it 30 meters? Is it 50 meters? Is it 5 meters? What is the value of the distance? And the second quantity is the sense of direction. In which direction are you moving? Are you moving towards north? Are you moving towards north or east or south or west? Or are you moving towards the right side or left side? Wherever you are going should be clear in the meaning of the situation. So since we are actually discussing vectors, we are not discussing, right now we're not getting into the left or right situation. We're just going to go by the terms north, east, west, and south. So if I were to describe displacement, let's say that this distance comes out as 130 meters. I know that this is distance, the total length of path between A and B, but in this circumstance, I can call it as displacement as well because it's a straight line and it is relatively the shortest path between A and B. If I were to find out the direction, for example, then what I should have done is from my starting position and with reference to my ending position, I should have drawn a grid at point A, namely north, east, south, and west, right? Now, what I would have done, or what I should have done, is mention the direction of this displacement. How can I do that? I can do this with two methods. For example, this angle comes out as 30 degrees. Then this angle would be 60 degrees. And be advised that this is supposed to be measured with the protractor, or so simply known as the D, right? You place the D over there and you measure these angles. Now, 30 degrees is with reference to east and 60 degrees is with reference to north. Both of these information are necessary for this final displacement. Now, I have the distance, that is the magnitude, and I have the angle. For its complete understanding, what I'm supposed to do is just give both informations but choose only one of the angles, because both of them are with reference to the grid. So I can either choose 30 degrees east or 60 degrees with reference to the north. Now, the way I will write this down is going to be different. So if I was supposed to write down displacement from A to B, I should have written down that the displacement from A to B is 130 meters. And now I have two options to complete my statement. For example, a student chooses 30 degrees with reference to east. They should write down 30 degrees north of east, or they could write down another statement to complete their answer as 60 degrees east of north. Basically, how to look at this is, for example, I explore the first option, right? So 30 degrees north of east. So from east side, move 30 degrees while moving towards north. While going towards north, count 30 degrees. So that is how you actually look at it, right? So now we have a magnitude and we have a respective direction as well. Now I will call this vector that is represented in blue line, the whole vector that is represented in blue line, to be displacement, because it has complete information now in reference to the displacement, right? Now let's explore some situations in which they actually ask you to find it out in terms of graph, or in terms of graphically, right? So they tell you in a question, very common question in past papers, that an object moves 500 meters due north and it moves 300 meters due east, right? Find the displacement from starting point up to the ending point, right? So let's draw this situation in terms of the vector diagram. How to make vectors and how to solve vectors is explained in another video. You can go check it out. But right now we're going to get into the understanding and mathematics of it. So for example, this is your starting point. Label this as ST. I usually do that, but you're not required to do that in examination. So you are supposed to show 500 meters due north, right? That is going to be the upwards direction. And from this point, the object moves 300 meters towards east. Now, you can draw this grid on a side, not to get confused along the lines while you're drawing the diagram. So we are done with the first vector. Now we draw the second one. So 300 meters towards east. This is 300 meters due east. Now he asks me about the displacement from starting and ending point. So this is my starting point, and this is my ending point of my journey. So between the starting point and the ending point, the shortest distance will be the green vector that I've drawn right now in the direction that is shown with double arrows, right? So this will be my displacement. Now how to find it out, how to actually do that, you can go back to the vector diagram, how to draw this by vector addition. But at the end of the day, the final answer would be inclusive of the angle. It could be either this angle X or it could be the angle Y. Any one of the angles can be selected, as I have discussed in this diagram, how you write down your answer in terms of the final question, right? So this is our final understanding of distance and displacement. One of the common questions that I've seen in these type of questions, these type of scenarios, is that they tell you that there is a circular track for running of athletes, right? The radius of this track is, let's say, given to you as 4 meters, right? So we draw a circular path that has a radius of 4 meters. So they tell you that the person starts from point A. There are a few points labeled on the circuit, point C and point D, right? They tell you that the person runs towards this side and then runs towards this side and then towards D and then from D back to A, right? First, sometimes they ask you to find out the displacement, the easiest case, between A and C. It's very obvious that if the person starts from A and finishes at C, the displacement would be the straight line between them. So the displacement will be 4 plus 4 as 8 meters. But if they ask you to find out the distance between A and C, then that would be the actual path taken by the person to go from A to C, which is half a circle, right? To find out the perimeter of the circle, we have 2 pi r. Now this is for the full circle, so we will divide this by 2 as we are only taking half a circle. So that would only be pi r. So this will be, r is 4, so this will be 4 pi. You can calculate this by putting in the value of pi and getting the correct answer or accurate answer in terms of this, right? Now we move towards part C. It asks you the displacement between A and B, right? So that path actually looks like this one. Now be advised that this is displacement, the shortest distance between A and B. This will actually look like a triangle to you in this format, right? So that would be a triangle that looks like this, which can be found out by hypotenuse by the method of Pythagoras theorem, right? So this is 4, this is also 4 meters, and we're required to find out the displacement AB, which is this one. So you can find this out by DAB whole square equals to 4 square plus 4 square, making 11 using the Pythagoras theorem, right? Then we have part D. It asks you about the distance from A to B. Be advised, this is distance, so that will be the actual path taken by the runner from point A to B, right? So that is quarter of a circle, so full 2 pi r divided by 4 to find out the quarter circle length. So that comes out as pi multiplied by 4 divided by 2, which is going to be 2 pi. And again, you can put in the value of pi to find out the correct answer, right? So these are, again, common questions in terms of distance and displacement. Next, we move towards speed and velocity. They're basically the same quantities, they have the same unit, but there is one difference between them. The first, speed, is actually a scalar quantity, and velocity is a vector quantity. Now, what we need to understand about them is speed can be written down without the sense of direction, and it will have its complete understanding. We don't need extra information to fully understand it. For example, if I say that a car is moving at a speed of 50 kilometers per hour, now we are not interested with this information whether it's going towards north, whether it's going towards west, whether it is going towards, let's say, right side, upwards, left, down, where it is going. This is not required with the information of speed. But when we talk about velocity, then the direction or the sense of direction has to be developed as the value is given to you. For example, if the person says, or if the examiner says that an object is moving at a speed of, so for example, at a velocity of 50 kilometers an hour, then they need to tell you whether they're going towards the right side, left, down, or up, or in terms of the grid where it's traveling. So sometimes they use the word they're moving in a straight line. Now, straight line actually gives us the guarantee that no matter wherever the object is moving, it will be in a straight line. So velocity, or so speed becomes velocity. For example, if I know that the object for its lifetime is going to be moving in this direction, I know for sure that between its starting point and the ending point, the direction is already known. It is in a straight line. So this will no longer be called speed. This will become velocity, right? If he tells you that it is moving towards the left, towards right, towards north, due west, due south, if the direction is mentioned explicitly, even then that speed will now be called as velocity because we specifically know where it is moving. Sometimes in the cases of free fall, for example, students sometimes confuse that if an object is under free fall, let's say with respect to the earth, object is moving downwards with a speed of 30 meters per second. Now I'm calling this as speed, but in reality this is velocity. Why? Because I know the magnitude, I know the value, but I also know the direction. It is moving downwards. Now since the information of this object going downwards is hidden in the word free fall, that object is moving downwards towards the earth, this speed will now be called as velocity. So we should be looking at these small hints in the question to refer to the value of speed either as speed or velocity, right? Now when we talk about speed, it is not required to mention the direction. It is just assumed that wherever it is going, it will be covering a distance of 50 kilometers in 1 hour if it is allowed to do so, right? So this is our speed and velocity, right? Now we move towards acceleration, one of the other concepts of kinematics chapter. So we move towards acceleration, right? The unit of acceleration is meters per second square, right? Sometimes you will find this unit as ms-2. Now, what is acceleration? We do see this definition in the book as change in velocity. So simply looking at the changing values of velocity, we can call that object, or we can refer to that object as being accelerating or under acceleration or deceleration when it is slowing down, right? So for example, if we have an object that is moving through time, for example, this is time equals to 1, this is time equals to 2, this is time equals to 3. Let's say the speed of the object at this point is 2 meters per second, and after some time we realize it is 5 meters per second, then it is 8 meters per second. So as a unit of time, as 1 second is passing by, the speed of the object is increasing. We can say that this is acceleration of the object, but by how much is it changing? So if I see the difference between these two velocities, there has been an addition of 3 meters per second to the speed. Even similar in the next case, there has been an addition of 3 meters per second to the speed. Now this 3 meter per second change in velocity from situation A to situation B is actually acceleration, which we so normally refer to as change in velocity. Is the velocity changing? Yes, it is changing. By how much is it changing? It's changing by 3 meters per second for every unit of time that passes by. So acceleration is change in velocity with respect to time. So we see that the velocity is changing by 3 meters per second in 1 second of time or time frame. So this becomes 3 meters per second square, right? So we have an acceleration of plus 3 meters per second square as this is being accelerated. Now be advised, acceleration can be or can have a value that is positive and can have a value that is negative. Positive and negative values both will be referred as accelerations, but negative value has a special name, that is deceleration. Sometimes it is used, sometimes it's not. Even if the examiner mentions that acceleration is minus 4 meters per second square, you should assume very likely that the acceleration is negative, which means that the object is slowing down. So even if the examiner mentions this negative acceleration as simple acceleration, you should consider it as deceleration. So a bit of wordplay, or you can say tricks from the examiner. So now let's look at a few numerical examples and see the formula what the acceleration represents. So the formula of acceleration is v minus u over t. Now what is u? That is the initial velocity where the object was actually moving, what previous velocity it had, and v is referred as final velocity, right? Now be advised, it is possible that the final velocity is greater than the initial velocity, in which case the object is accelerating. In some cases the final velocity may be less than the initial velocity, in which case the object is decelerating or is under the influence of drag or braking or friction, right? So we are going to move ahead from this idea and go towards this in terms of numerical perspective. Let's say that the object is moving at a speed of 5 meters per second, and after about a time of, let's say, 10 seconds, we see now that the object is moving at a speed of 20 meters per second, right? So 10 seconds has gone by. This is the time frame that we put in this formula. Now, if you have to label what's what, this will be my initial speed as u, and this will be my final speed as v. Now, if you put this in the formula, we have v minus u over t. This becomes 20 minus 5 divided by the time taken for the process, which is going to become 15 divided by 10 equals to 1.5 meters per second square, right? So it is accelerating at 1.5 meters per second square. Now, what does that mean? It means that if I were to look at this object after every second up to a time of 20 seconds, what would have happened with the speed of the object? So the time passing between these two slots is time equals to 1 second. So this is time equals to 1 second, right? Initially, it had a speed of 5 meters per second. Now, if we know that the acceleration is 1.5 meters per second square, so the change in velocity should be 1.5 meters per second after every 1 second that passes by. So this will be 6.5 meters per second after 1 second, and after 2 seconds, in the next second, it will be 8 meters per second. Again, notice that a change of 1.5 has taken place between these two positions, right? And this is my value of acceleration, that for every passing second, for every 1 second that is passing by, there should be a change of 1.5 from one step to the other. Now, from the starting point, if 10 seconds had passed by, let's say t equals to 10 seconds have passed by, then the final velocity at this point would have been 20 meters per second. So this is how we visualize acceleration, that after every single passing second, the speed is changing, or the velocity is changing by a certain amount which is given to us. Now, since we are referring to a fixed number of acceleration, this is considered as a uniform acceleration, in which the value of acceleration is constant. It's not changing between the changing times. I know for sure that in the early stages of its life and in the final stage of its life, it will still be experiencing a change of 1.5 from starting point to the ending point. But then we encounter non-uniform acceleration. Then we encounter non-uniform acceleration. What is non-uniform acceleration? Basically, we cannot give a fixed value between different times of the object. Now, let's say that the gap between the systems, or the timestamps between them, is a difference of 1 second. There is only 1 second passing by between these two situations, right? Let's say that the previous speed is 2 meters per second, then it achieves a speed of 6 meters per second, then it achieves a speed of, let's say, 12 meters per second, and then achieves a speed of 30 meters per second. Let's calculate the difference of speed between the two stages. So this difference comes out as 4 meters per second, an addition of 4 meters per second. This comes out an addition of 6 meters per second. This comes out as an addition of plus 18 meters per second. Previously, we had seen that there always was a fixed change, a fixed value increase between the stages of acceleration. Even in this example, we had a fixed value of 1.5, and in final stages it was 1.5. Over here, the change is not uniform. It is changing at changing times, right? So this was its journey at time t equals to 0. This was after t equals to 1. This was when 2 seconds had passed by, and this was when 3 seconds had passed by. So there is a non-uniform change in acceleration. Similar case could have been observed, that this is quite possible that first it is 4 meters per second, then it could be a change of plus 2 meters per second, then it could be a change of plus 7 meters per second. So even acceleration can either reduce and then again increase again, or it could actually be in an increasing fashion, as explained in the situation above, right, in the orange color. Similar case could be observed in deceleration case as well, that the previous deceleration could be between objects or between different times of the object. It is possible that it is, let's say that it has a speed of 30 meters per second. Now it is moving at 25 meters per second, then it is moving at 10 meters per second, and then it is now stationary at 0 meters per second. So we know that it is decelerating, it is stopping by, right? Again, the timestamp between the situations will remain 1 second, 1 second, and 1 second. So we see a reduction of 5 meters per second. So this is considered as a case of deceleration, right? Over here we see a reduction of 15 meters per second. Over here we see a reduction of 10 meters per second. Now keeping this 1 second in constant, that is why, so that this comparison of per meter per second becomes easy to understand. You can notice that the object is decelerating, but the value of deceleration in each stage is not fixed. And again, this will be considered as non-uniform deceleration. So this will be non-uniform deceleration. For those who are wondering how to calculate this, we cannot calculate this. We don't have an equation for this. And even up to A levels, we only deal with situations which are dealing with constant acceleration, right? Basically these cases in which the acceleration is not changing. Now there is another case for acceleration and velocity that comes from the circular motion. Just going to touch this part at this point, circular motion. Now what happens in circular motion is, for example, if an object is moving in a circle in this trajectory, they often refer to you as whether the object is accelerating or not, right? So the acceleration is towards the center and the velocity is tangent or at angle of 90 degrees with reference to the acceleration. And the centripetal force will also be towards the center, according to the second law that force and acceleration are proportional if mass is constant, right? I've explained this in another video, but going back to this topic, just to have an idea of what's actually happening. So what if the object actually moves through this line of sight? It actually keeps moving, comes to this point, right? And now the vector of velocity is towards this direction and the acceleration as pointing is always towards the center of the circle, no matter the direction of the object. So again, the acceleration at the center, velocity will be in this direction, right? Now he asks you whether the object is accelerating or whether it's not accelerating. Students generally write down that it's not accelerating. Why? Because the velocity, let's say if it is 7 meters per second, it will still be 7 meters per second. It will still be 7 meters per second. But if you say that it is not accelerating, that will be an incorrect answer. Why? Because velocity is a vector quantity and it needs magnitude and direction for its complete understanding. Now we understand that the magnitude is remaining constant. It's not changing and it is 7 meters per second, right? But the direction is not constant, it is changing. So even though the direction is changing, we should still assume that it is an accelerating situation. The object is experiencing an acceleration, right? Because the direction of the vector is changing, right? And even so, the direction can only change if there exists a resultant force, and resultant forces cause acceleration. That is why wherever this object may be, it experiences a force towards the center, which forces the object to move in a circular path. So since there is a resultant force, there must be an acceleration, even if the value is constant, right? So that concludes our lessons for today. We will move towards the graphical analysis of kinematics, speed, distance, time, velocity, and acceleration in another video, right? That is all for today. I'll see you in the next class.